Now we come to the Cype software, and you can see this is a Cype software functional design of the building. So now we are going to explain you how to get the structural detailing or structural design of the building we get from the Cype software. So you can see this is a Cype software. So before you use this software, I would like to say you something. So some plan you will get without a scale. Suppose this is in inches or feet. We are talking about this plan. This is inches or feet, but when we are using a Cype software, then we have to import the drawing in a meter only. So how can we convert the feet drawing into the meter in a meter? So how can we convert the unit of the feet drawing into the meter? So let's check. You go to the new window, and you have to change the unit. Just I want to convert the feet to the meter. Just give the unit command, just give the enter and set here. Okay, it's no problem. I'm going to set a meter only. Just give the OK, and in the similar way give the dimension D command. I give the enter. You will get the dimension style manager. So I am going to convert here only to, so give the OK. So we have the beautiful option here. You go to the insert and you can convert your drawing. Suppose I want to convert this plan into a meter, so give the OK and select anywhere. So you can see this plan has been converted in meter. So in this way we can convert into a meter. You can see we have converted this plan into meter. So if you want to check the dimension, you go to the dimension command and you can check the dimension here. This is in a meter. So in this way we can convert any drawing into the feet to meter. So this is a very wonderful options we have how to convert. So in this way we can convert any drawing from the one unit to another unit. So to use in a Cype software, what we have to do, we have to suppose I am going to erase everything here. Just erase this. So only the structural part I am going to take in a Cype software. So I am going to delete all the things. So if you want to create the grid line, so we have a beautiful option. You go to the annotate and center line. So select these two lines. So we might get the center line between the 2 points. So which is a very helpful to create the grid between the column. So in this way we can create. So we have to also set the any one points to the 0 0. So select all the drawing, select all drawing, give the move option and select this point, select the any point here and come to the commands again, keep the 0, 0 and give the enter. Now you can see we have the coordinates and if I start from the 0 0 only, so it is a very important to know. So in this way we can convert the drawing into feet to the meter. And then after you just Ctrl+S to save this drawing. Just I am going to save here. You can save anywhere, but now I am not going to save this drawing because I have already created this drawing. So you can see this is drawing I have created. So you can see we have for the stair we have the 2.5 meter and story height is 3 meter, and we have a G+2 story building and ground. The foundation level is totally 1.5 meter we have considered here. And you can see we are going to use the dead load or live load for the residential building. If you see the IS 875, then what we will get, we consider only 1.5 kilonewton per meter square for a dead load of the residential building, and live load we are going to take the 2 kilonewton per meter square. And we use the IS 456 2000 for the concrete. This is a concrete core, and this is a 5 story because we consider as a foundation is a 1 story and total 3, and this is a 4 and 5 story building we're going to consider. So we want to import this file into Cype software. So how can we import this file into Cype software? So let's go to the Cype software. So you can see this is a Cype software. So how can we do? So go to the Cypecad. So go to the new, write the name. Just I am going to write the name of the project just and give the accept. Sorry, we have the new 3. So give the accept. No beam models we don't have, so give the no here. Select the impd one, give the accept here. Now you can select the what the grade of the concrete. Just I am going to use the 20 Newton per mm square grade of a concrete and 20 down, and you can check. You can also select the codes, and we have to study the different code also. Suppose IS 445C is concrete code, and we have to study all the code. 875 part 1, part 2 and part 3 it is for live load and dead load, and part 3 is actually for the wind load. And suppose we are doing a work for the machinery design, then we have to learn the IS, we have to know the IS 1905. So this code we have to learn, then only we can able to do a design. So give the accept, simply here accept. So I am going to give the accept here, give the accept, give the accept. So this is a Cype software. So I want to import my drawing file. So go to the edit template and just select your file where you have kept. I have saved in a desktop only, so I am going to select this is my desktop file. So I want to import this file. Yeah, you can see this is a file, and this is my building plan, and so I am going to import this one. So at first I am going to create the floor. So go to the plus option, and you can go from the other also, and general dot another general floor, delete the floor, give the accept here, and I am going to make the 3 meter now, but I will going to change this all whatever we require. I am going to take live load 2 kilonewton, dead load 1.5 kilonewton, and giving the 5 story. Just click and just click this option. So now I am going to edit this option again, and just I am going to keep the foundation is 1.5, and I am going to take the minus 1.2 meter down. So it is down here, you can see here. In the similar way we can go for a load also, because in this there we don't have any slab, that's why we are going to take a 0 only. So take the 0 and give the accept. So we can do as I have shown you. Then again what we have to do, go to the column size, go to the column, add the column, and here in a x direction what we have a 25 centi. So type the 25 centi, and 30 centi we have in a y direction. So I am going to select. So I want to on the ortho, just active, clear all, and only select the end point. Just give the accept, and we can accept here. So after the putting the column, we have to bring it a proper position. So what we have to do, we have to go to the adjust command we have. Here you can see the adjust. We have just select this, give the OK, and click only which side you want to move the column. Just I am selecting this all the column here, move to have this in a proper positions. So I am going to make all the columns and proper positions. Now we have here we have the circular column. So how can we do the circular? Go to the again column and select the circular and giving the 30 centimeter, and the similar way we can do. and just give the accept. So again you go to the OSNAP and just select the midpoint. Just I am going to select this midpoint. So this is a column, how we have set up the column in the proper positions. Now we go to the beam definition and we can define the beam from here also, beam, or you can go use the sort command. We have the beam option here. So I am going to use the dimension, that is a 20 cm by the 45 cm. Just I am going to accept this, and we can also on our plan also. So on the plan, so justification I want to change, so I am going to, so again you go to the snap and select the nearest one. So you can ortho you can on. Just I am going to this on this ortho. After that we have the beautiful option, that is extend, how to extend, and just select this option and extend all the beam. So I am going to on these options, extend all the beam here. Now I am also going to put the beam here also. Just select this and keep there only. So you go to the extend option and you extend this beam. Now we have to delete all the extra beam. Thus I am going to delete this all the beam here. Now you can see what we have done. We have arranged all the beam here. Now I want to keep the slab here. So go to the slab, give the 120 cm or 12 cm and just give the select admit and select the any beam. Now I am going to go copy option, just copy this slab, give the accept, and you can select all. So now you can see what we have done. This is our building plan. So again we have to set the wall load here. So I have already told you how to calculate the wall load, and this is a wall load, just a main wall load. That's width is a 0.23 and height is a 2.55. Total height is a 3 meter, but we have to subtract the depth of the beam. That's why it is a 2.55 into 22. That is a density. That is a combination density of a brick and cement mortar, that is 12. So we are considered 13 kilonewton of the main wall, and we have partition wall. This is a total 9 kilonewton, and for the railing we are considered a 3 kilonewton per meter square. So in the same way we have to select, we have to apply the load also, but wall load we should not have to miss, otherwise it is a huge load. So I am going to select the load. Sorry. Go to the lower line load on a beam and giving the 13 kilonewton. So give the 13 kilonewton. So partition wall load we go for a 9 kilonewton. again you go to the 3 kilonewton. That is a railing load that we are going to put here only. And we want to delete this load here, just delete it and create the load that is 3 kilonewton, and just it's okay, no problem. Again you can type the 9 kilonewton load and this beam and this beam. Now we have to now you can see in a 3D what we have done. Now again we have to copy from all the level. So to convert we have to go for the slab also. Go to slab, fixity. So we are going to take 0.01 to convert the flat slab into the normal slab, assign to all, and finish this. You come to the next floor. So you come to the next floor. Yes, I am going to next floor. Go to the group, copy from another group. Just I am going to select this one, and again go to the other floor. Similar way you can select. Copy and select this. Now you can see what we have done. This is a structural modeling we have done here. So how can we, here we have the STR only, we don't have any slab here at the top. So how can we do? So come to the column definition, and we have the edit option here. So select this column and make to the up to 4th floor only, and just give the accept. We can also use the copy command. Just copy, save this angle and initially dimension position, accept. So select all the column here which you want to reduce. Thus I am going to this column, this one and this one. So you can check in a 3D what we have done. So we are going to delete all the, so you go to the last floor and delete this, all the columns here. Yes, I am going to select this column, and load also we can delete from here. So select all the loads from here. Now you can see in a 3D what we have done. And again what we have to change here. So delete this load also. Go to the load and delete this load also. And we have here the 13 kilonewtons, so we can go through it. Thus I am going to take the STR load, that is a 30 kilonewton per meter square. So I am going to take this 30 kilonewton. You come to the next floor. What we have here, here we have the railing only. So I am going to select the delete option here. So go to the loads and delete. So I am going to select all the loads can be deleted from here. So only we are going to keep the railing load. So give the 3 kilonewton, just give okay. There we have the railing only. So again we are going to take the 9 kilonewton this side and this side, but we have to take the 30 kilonewton for the STR. That's why I am taking the 30 kilonewton. And again you come to the down, and again we have to delete that. There we have to take the 30 kilonewton. We are taking 30 kilonewton for the STR. So I am going to delete this option again. This load I am going to delete and take the load of the 30 kilonewton. Again come to the next, delete and delete this load. Sorry, So I am going to take I am delete this load and again go to the load and give the 30 kilonewton here. So come to the down again, get the 30 kilonewton and we have to delete this load. Now you can see the model what we have done. So in the similar way, we don't have a slab at the ground level, so we want to delete the slab. So go to the ground level and go to the slab panel manager and delete. So I'm going to delete all the things from here. So you can see what we have done, and this is our complete project. So what we have to do, this is our complete project. So what we have to do, we have to go for analysis. You can see I have changed this analysis. Only dev load and live load we are going to consider. If you go for the wind load and the seismic load, it increased the 20% of the building cost. So now I am not going to take to accept and give the analysis here. So after the analysis, what we have to do, we have to close this and go to the result and go to deform shape, and you can see the deflections. So I'm going to see the combined deflections. So we have a two deflections we have. This is a temporary deflection and permanent deflections. So a temporary deflection is given by the software only. This is 2.0 mm, 02 mm, but permanent deflections for the serviceability of the building that we consider for the 30 years. That's why we are going to multiply 2 into 3. That is altogether it is a 6. So we have to according to IS code 456, what for the deflections limit for the deflection is span by 450. So span by 250 we have, span by 250 we have. So if you calculate this, this deflection might be greater than this one, permanent deflection. So we can conclude that our structure is safe in deflections. So in this way we can conclude the shape and size, what the size we have considered might be the more economical sections. So again you go to the result and you can check how the column has been designed. So this is a column design. So each and every thing you can check by the software only. So I am not going to explain you everything here, but we will do next video. So you can check a beam also. So this is a beam. So after that what we have to do, so how can we generate the structural drawing from this software? So we have the beautiful option here, drawing of generator option here we have. So in this way we can do the project in Cype software. So you can see all the detail of the reinforcement very easily, and you can also generate the analysis report, but now I am not going to generate the analysis report only. So and I am going to take one similar structure that I have done. This is a similar structure, and we have how to put the stair. We have already uploaded the video, so you can watch this video how to upload the how to do the staircase in a Cype. So we can do very easily here. So now I am going to generate the drawing. So go to this option, drawing generator option. Here we have, and we can generate the different drawing. So details of all the drawing, and you can get all the drawing whatever you require for the construction of any project or residential building. So if you want to export in AutoCAD, you go to all the drawing in one file, and you can select the folder where you want to save this drawing, and give the file name also you can give, and display the file with the associated program. Just tick this option and go. Now you can see all the drawing have been generated by the software automatic. So it is a very important for the engineer to judge the what is the section and what might be the sections we have to consider for the beam and column, whether the shape and size have been resist the load or not. So we can do it very easily by the Cype software. So I haven't explained you how to do the foundation, so go to the foundation. Here I am going to off this so DWG file format I have off here. So how to do the foundation? Here you go to the foundation element, just close and new. Just I am going to select the square one and just give the shape and give the all the foundations here. And I want to combine here, combine footing, so I am going to select the combine one. Just cancel this, just drag and this is a combined footing. So if you have the boundary condition, then also you can change. Now I don't have any boundary conditions, so double tie beam. So I am going to add the strap beam, so I am selecting the balance one and just connect the one column to another column. To use. So double tie, why we use a strap beam or double tie beam? Because when we are using the eccentricity footing, then what we have to see, the stress or the bending moment which is developed by the weight of the building cannot resist. So we are going to balance the movement or balance the stress between one footing to another footing. That's why we required. So go for the design. And in this way we can design the foundation. If you want to see the what might be the reinforcement in the foundation, you just go to the edit and select the any foundations, and this is a foundation design. If you want to see the 3D model, you can see the very easily here. So in this way we can complete our project, as everything we have the cover in this video. So you can also get the very easily to generate all the drawing and all the detail. So I am going to show how I have prepared all the drawing. So, and this is a structured detailing we get from the Cype software. You can see all the details we have got from Cype software. This is the details of the beam. This is a column detail we generate from the Cype software, and this is a layout, and this is slab details, and this is a staircase details we have. And we have to also create a title for when we are going to submit this. So give the check this drawing, and we have a given so everything, and you have this all the drawings which I have done. This is generated by the Cype software, and this is the functional design of the building. This is generated by Revit software, which you can see. This is generated by the Revit software, automatic generator. I have already shown you how to generate the all the drawing details. This is called the functional design. Functional design we can get the very easily by the Revit, but the structural detailing we can get from the Cype software, and combine all the books. At last but not a least, but we have sometimes we have the scale problem. So how can we solve the scale problem? Suppose now we have in inches or feet, but we want to submit the drawing in 1:8 feet. 1 inch equal to 8 feet. We want to submit. How can we solve the scale problem here? So a little bit I want to discuss with you. So as you know, the what is the paper A4 sheet, dimension of the A4 sheet is a 12 inch by 8 inch. So when we are going to take the printout, so the what we have to understand, the 1 inch is only in a paper, but in a side this is a 8 inch. So 8 feet, so sorry 8 feet, 8 feet is represented by 1 inch. So I am going to give the example 1 inch equal to 8 feet. So here I am going to create the rectangle. So just create. So if you multiply the 12 into 8, it is a 96. So I am going to give a 96 feet here. And the similar way we have 8 into 8, this is a 64 feet. So I am going to create the 64 feet and there 96 feet. And C for close. So this is our paper size. When we after the converting the 1 is to 8, 1 inch equal to 8 feet. So what we have to do, we have to leave a little bit of space for a bending purpose. So I am going to give the X command, explore all the things, just explore all the line. So I am going to give the offset here. So I am going to take a 6 feet for the bending purpose, and this side I am going to take only 3 feet. So all 2 feet I am going to take the 2 feet. Sorry, 2 inch it happens. Give the offset, give the 3 feet. Just I am take the 3 feet from here. So I am going to trim this. So plate. So multiple, just I am select the multiple here and give the 0 only, give the enter. So just I am going to delete this. So I am going to copy this drawing. So just copy command, just give the enter and just keep their file. Now I want to get the print of this. So give the Control plus P and DWG to PDF and select the A4 sheet. Just I am going to select this A4 sheet and select the window here. Just I am going to select this and center to the plot. Center to the plot and fit to the paper. We have to off this option. You go to the inches and here we have to change the 96. So 1:96 scale we can do. So just you can see the preview. So this is a preview you can get. So if you want to get the multiple scale you can use. Suppose again I want to keep this drawing 1:40. It means 1 inch equal to represented by 40 feet. So how can we do? Just select this all the drawing, give the SC command for the scale, just give the enter and select the any base point and give the 1/5 because I want to 5 times I have to make it a small. So dimension we have to edit, or how can we change the dimension? So delete this and go to dimension, command D and create the one dimension. Sorry, so the new dimension, just I'm going to type my name only, Govindra. And so here we have to give the multiple factor 5 times. Just give the accept. Now you can check on the what is the distance between the 2 points. So it is a nearest 3 feet. So it is a 2.66 feet. We have this 3 feet, but we have taken up to here. So in this way we can again just copy, select this drawing and put there. So this scale of this drawing is 1:8. 1 inch 8 feet is represented by the 1 inch. In the similar way of if you see the this plot size, then 1 inch equal to 40 feet. So in this way we can solve the scale problem. Hope we have explained each and everything from till now. So watch once nicely, or twice or three, you might get knowledge from this video. So thank you for watching.